Today we're going to solve equations involving x and y, and this is really what you did in grade 10 math. So again, what does it mean to solve y equals x plus 3? Well, all it really means is we need to find the truth. And the truth is we need to find all the x and y values that make this equation true. Make this equation work. And again, we simply want the left-hand side to equal the right-hand side. But it's a little bit different than what we did last day. So think of a solution for this. Think of an x and a y that make this work. And I think probably one of them that you might come up with is when x is equal to 1, y is equal to 4. So 4 is equal to 1 plus 3. That's true. But is your solution the only solution to y equals x plus 3? And I hope you say no, especially if you picked a different one than me. So as it turns out, there's going to be a lot of different answers to y equals x plus 3. And one of the ways we did this in grade 10 graphing was we made a table of values. So that's what I'm going to do. I'm just going to make a quick little table of values, and all of these work. And again, if you want to see that they work, just plug them in and make sure that it actually does work. So I've done these already, and I'm just putting them in for us to look at. And they're in no particular order. But anyway, so in looking at the 2, 4, 6, 8 solutions that I did, is it possible to write down all the solutions? And I hope you remember that it's impossible because there are an infinite amount of solutions. There are an infinite number of solutions. So really what we need to do is we need a way to represent all of the x's and all of the y's that make that true. And the way we simply do that is plot it. And when you plot these points, again, I'm going to quickly plot them. 1, 4, 0, 3, -2, 1, 7, 10, up here, -7, -4, down there, -10, -7, -4, -1, and finally 4 and 7. So when you plot the ones I've plotted, what you'll notice is they all line up. And again, for you, I want you to actually use a ruler, but this computer won't let me, so I'm just going to have to draw the best line I can. Now again, the reason we can connect the dots is every single point in between that lines up is a solution. I chose to not pick 1.4, 4.4, an example like that. I chose nice points. And if you've watched any of my other videos, a nice point is a point that can be placed exactly on a grid. So they're integers. So where do you think the other solutions of this would be on the graph? Well, all of those other infinite amount of answers would be other places that line up with the ones we've done already. So for example, if I picked -2, 1, or -3, 0, or 2, 5, all of those places would make that equation true, and they would line up. So the key idea then is we can actually represent the truth. We can represent the solution to this equation by drawing a line. And again, your brain loves pictures. Pictures are really good. We're going to rely on pictures a lot this unit. So I'm just remind you of that grade 10 math. Okay, so again, I just want to work through a quick couple of examples and then have you practice a few and remind you of a few things. So I want a table of values for this. Of course, in grade 10, you learned a fast way of doing this. But for right now, let's stick with a table of values. And I'm going to give mine. I'm going to just plug mine in, give you a quick review of how I figured out the y values, and we'll plot. So again, all I did was I plugged in for x and I solved for y. So for instance, with this one right here, -1, 5, what I did was I plugged in 2 times -1 minus 3. That equals -2 minus 3, which is -5. And for this one right here, I plugged in 2 times 3, which is 6, minus 3 is 3. So again, if you have one of the letters, the x's and y's isolated, plug in on the other side and figure out what the y is. So when we go ahead and plot these points, because we want to find the truth, all of the answers to y equals 2 minus 3, let me go ahead and plot these, and hopefully we remember it's going to be a line, but let's see. So -4, -11 is down here, -3, -9 is right there, -1, -5, 0, -3, 2, 1, 3, 3, 5, 7, and finally 7, 11. And if I ask you to describe this relationship, I hope you say it lines up. So we have to draw the line because, again, these aren't the only solutions. There's a bunch that, I didn't do one. So, for instance, 1, -1 is on there, and 4, 5 is on there, and 6, 9 is on there, and -2, -7, etc. We didn't figure those out because, again, we know that they line up. And given they line up, and given I understand I don't want to find decimals, I can connect those dots. Okay, one last one to remind you of what you want to do when you graph. So same basic idea. I want to figure out some x's and y's that make that work, and then I want to draw the answer pictorially. So the key thing right here is, given that we have a fraction, if you remember from grade 10, that represents slope of a line, but for right now, we're making a table of values. So again, if we want nice numbers, we have to pick nice values of x. And again, we need nice values of x because we don't want decimals, we want nice numbers. So basically, we need to pick values of x that get rid of the fraction, and as long as you have x is an even number, the fraction will go away. So again, I'll do one example, -8. I plug -1/2 times -8. Always make it into a fraction if you have a fraction, and this is equal to 8/2, which is 4, and 4 plus 1 is 5. I'm just going to fill in the rest, and you make sure that it's working out. Okay? Okay, so now I'm going to go ahead and plot those, because that is not the answer to the question. Remember, there's an infinite amount of answers. We need to know how to represent it. So -8, 5, negative 6, 4, negative 4, 3, negative 2, 2, 0, 1, 2, 0, 4, negative 1, and 6, negative 2. And again, those points line up, and we haven't gotten them all, but that's okay. We don't want to find those in-between points because they're not nice. And that's what our line looks like. That's what the truth looks like. So we're not talking about y equals mx plus b right now. We're just trying to understand that when you have an equation that has an x and a y in it, there's an infinite amount of solutions, and we need a way to represent that. The way we represent that is graphically. And in these examples, in this unit, it's always going to be a line.